Hello all and welcome to the Gestalt IT Rundown, your weekly look at the IT news of the week. I'm your host, Rich Stroffolino. I'm an editor here at Gestalt IT. Thanks for joining us. Ordinarily, I'm joined by a co-host. We run down a coterie of stories that happened over the course of the week, IT related, of course. This week, we're doing a new experiment. We're going to be doing a solo edition. I'm by myself. I'm here enjoying the lovely offices of Gestalt IT, and we're going to be talking about one particular story that caught my eye. This week, we're going to be talking about one from Microsoft. Now, they recently produced some new details about their Project Silica. This is an interesting new storage project that they're working on. It's been in development for a little while now, but we're just starting to see some details and kind of the first fruits, somewhat practical, on something that's been mostly theoretical up until this point. If you haven't heard of it before, Microsoft kind of has a thing for weird archival storage. We've actually covered on Gestalt IT their efforts in the DNA storage space. Check out our piece, DNA Storage is Weird, back from 2017, I think, where Microsoft had kind of put out their first fruits of that effort and some of the amazing possibilities, but also some of the incredible technical challenges that go along with storing stuff on DNA. Basically, the long and short of it is super high density, super expensive to write to right now, and the read times and access times are ridiculously bad with current technology, and that would need a lot of development over time to kind of get it to where it's anywhere practical for any kind of archival storage. Project Silica is another effort in looking into this long-term cold storage problem that's out there. Now, to kind of give the landscape, obviously tape has a long history when it comes to archival storage, has a lot of great properties. It's really dense compared to disk, or especially to SSD or anything like that. Doesn't need active power necessarily to store it. You can just put it in a temperature controlled room, and you're pretty good for long-term archival storage. The access times aren't great, when you have to spin something up scan, you have to kind of scan all that tape, and you have to kind of really know what's on that tape to really best take advantage of it. If you just have a bunch of unlabeled tape, I don't know what situation you're in where you have a bunch of unlabeled tape. I'm sorry for you if you do, but that could theoretically, the access times on that could be really bad trying to find out where stuff is. And there's also like the physical time to run through the tape to get to a particular point has some certain practical limitations. Obviously, if you're using it for a long time, cold storage, it isn't that bad, but this is where Project Silica comes in. They have successfully written data and considerably dense data into a 75 by 75 centimeter wide and long, and then a 2 centimeter thick piece of essentially acrylic glass. And this is a really interesting development for a number of reasons. This brings in three-dimensionality into storage in a really interesting way. I don't know if three-dimensionality is a word, but I'm going to go with it. It essentially allows them to do three-dimensional structures to store data. They actually use the same kind of lasers that they use for LASIK eye surgery on this. I don't know why that's interesting. It was in the article I was reading about this, though, and it just caught my eye. But it does it to actually warp the physical structure of the glass. So I don't know if this is going to be something that you're going to be reading and writing to all of the time, but it physically changes a small 3D structure within the glass, and they call that a voxel. They associate it kind of similar to a pixel in a two-dimensional space versus a voxel is a three-dimensional representation of that. And then that can be stored in that 2 centimeter thick space. You can have a stack of over 100 voxels. So you can imagine 75 centimeters wide or not 75 centimeters up and down with that 2 centimeter thickness. You're looking at quite a number of voxels that you could theoretically store there. That is then read by light passing through that, and it uses some machine learning algorithms to actually determine what's on there. There are a number of interesting implications as to, hey, why do I want weird 3D glass storage? I mean, maybe you don't. I think it's cool, if nothing else. But the whole point of it is it doesn't, similar to tape, it doesn't require active power management, but it's really resistant to any kind of temperature or environmental changes. So you don't have to store it in a special environment. They were showing somebody dipping one of the plates of glass with data stored on it into boiling water. Again, I don't know necessarily how often your tape is falling into boiling water, that's a problem, but kind of just showing that the extremes of temperature don't really bother the storage media, which is really good when you're, worried about retaining data for the long term. And Microsoft is interested in this because, I think they bring this up in the piece that they shared on this, that a lot of people think when you store stuff to the cloud, it's just living up there and it's magical and I don't have to worry about it and it just comes magically back down. Or even if I store it in Azure Blob or some of their longer term storage formats. It just sits up there and it's fine. Well, that actually has to get written to somewhere. Obviously, there's like a physical representation, or there's like a physical machine that has to store that data. And quite a lot of that data, once it's put up into storage, isn't accessed for very long periods of time. So Microsoft, obviously, as a cloud provider, interested in long-term archival storage. There was also the aspect of media storage that Microsoft is addressing, and that's where this particular announcement comes from. They announced in association with Warner Brothers, they did this where they stored the original, film edit for the 1978 Superman film onto this piece of glass. And that was a really interesting point to me. One is that these production houses have to store the archives of this film, both in digital and film formats for long, and plan, as a cultural artifact, plan to have that in storage for a very long period of time. And that's actually something that they have to access fairly frequently, whether in the digital or in the original film component, because as formats change, they want to re-release things in either higher definitions or new scans or new restorations and that kind of stuff. And that is something that actually has to be accessed over time repeatedly, but also protected and for very long-term storage. So it provides an interesting challenge. And, thinking of, film is basically 100 years old or slightly older than 100 years old, and thinking about how we're going to store that for much, much longer when we're looking at classic works of film and TV and that kind of stuff, to save those long term is a unique challenge. The other aspect of it that I thought was even more interesting was things that were never on film that we are now wanting to preserve, things that were kind of digital only. And they said currently, what they do right now is they put that on film. They take the bits and they make an analog representation of that. And then when they want to, if for whatever reason there was an emergency and have to bring that back, that whole process is very lossy and isn't the best when it comes to long-term storage. Something like Project Silica, storing it in glass and being able to have this extremely high density storage is very interesting, especially as we're increasing the volume of digital media that we're going to want to store long-term. We need something that's very dense. The other interesting thing is in terms of Silica this Project Silica media as a storage medium, I think is very interesting because unlike tape, again, where there's a beginning and an end to a roll of tape and you have to unroll it and kind of read to that point, then roll it back if you want to get to different points on the tape. The way that the 3D or that the light reading, the light read head, I guess you would say, for this is that it can kind of move in any axis all at once, so you can get theoretically much faster access speeds. Now, I say theoretically because we don't actually know how fast or how expensive it is to store stuff to here. I've looked around quite a bit and I haven't seen any kind of read-write speeds. I haven't seen any kind of cost per gigabyte or anything like that, which tells me it's still strictly in, let's call it science experiment territory. At least when we were looking at Microsoft's efforts into DNA storage, they were willing to say, hey, listen, we were able to write, 6 megabytes of data to this DNA and it cost $2 million. And, I'm just throwing all these figures out here, but they were able to give us some concrete numbers in terms of how much was stored, how much it cost to store it, and then what the retrieval times theoretically would look like. And we're not even seeing that with Project Silica right now. So I am dubious. But as long-term storage becomes more and more important, we've seen a number of different approaches to this, and seeing this kind of glass-based storage, or I think it's technically an acrylic, but let's not get into semantics here. This kind of approach to storage for long-term, something that is doesn't require any active power, isn't going to wear out over the course of a relatively short period of time, whether that's 5 years, a decade, 20 years, or something like that, and that can be kept in virtually any environment or most ordinary environments without fear of degradation, is really important. And I think will, theoretically, if they're able to commercialize that and offer it, have some interesting long-term benefits down the road. Plus, it looks like sci-fi where they store stuff on crystals, aka Babylon 5, which is my ideal future. That just about brings us to the end of the Gestalt IT rundown for this week. We're here every Wednesday at 12:30 p.m. Eastern time, so make sure you check us out, like the Facebook page, follow us on YouTube, subscribe on YouTube is actually how I would say it. You follow on Twitter. You can follow @GestaltIT on Twitter as well. We always post links to all of this great stuff there, so be sure to check that out. You can find my writing on GestaltIT.com, along with my colleagues Ken Nalbone and Tom Hollingsworth. You can check all of their good stuff out there, and you can follow me on Twitter @Mr. Anthropology. That's MR Anthropology. Until the next time we meet, remember everybody, have a super sparkly day.